Hello everyone. Today I'm going to introduce recent topics in DBMS database systems. So first of all, let me explain the concept of big data. In fact, the big data has no formal definition, but usually we define big data as 3V: volume, variety, and velocity. Here, the volume means the capacity or scale of data. So usually, if we consider the big data, the data size is usually big. So the size of data is usually petabyte, and it will be exabyte. And 1 exabyte is 10,000 petabyte. And we also consider the concept of variety, meaning that the types of data are different. So to handle the big data, we consider the structured data, which is the conventional data format, as well as unstructured or semi-structured data, which is a little bit different data types from structured data. So it means that we need to consider various data types for big data to consider text, image, and other types of data. And last, the velocity is related to real-time performance. So it means that when we perform the data processing, we need to consider real time, and we need to consider streaming data. So data continuously updated, and in this environment, we need to handle the data. This is the concept of velocity. So for now, let me more explain the 3V concept in more detail. First of all, let me consider the volume, which is related to scale. So this is one of the popular report, the published in IDC, International Data Corporation, and in 2018, they estimate the size of data in the world has reached 33 zettabyte. Here, 1 zettabyte is 10 to the 21 byte, and which is same to 1 trillion gigabyte. So in our country, everybody try to use 1 terabyte. The data size of 1 zettabyte is much more than the number of the population in Korea. So this is really huge. And 2018, this data size is 33 zettabyte, which is really big. And now 2020, it is more than 40 zettabyte. It is really huge, and the data size still increase every year. And in 2025, the data size will reach more than 175 zettabyte. This is really huge. So it means that every year the data size increase exponentially. So to consider this trend, we need to consider the efficient data processing. And another concept is variety, which is related to structure, and it means that we need to handle different types of data. So in our database class, we mainly focus on the relational data, which here the data type is tables. But to consider different types of data, such as text, semi-structured, tree-structured data, graph, and streaming data, we need to handle different types of data. In fact, these types of data are much more, the size of these types of data are much more than the size of relational data. So to handle different types of data, we need to consider, it is very important to consider different types of data in big data processing. Okay, and in my opinion, personally, I consider in the big data processing, the considering the variety is very important. And this is an example of variety. So as you can see, for the one customer, she or she, this user is related to different types of data. They related to some social data. This is graph data, and the user also related to the banking finance, which is the relational data, and the user also related to other types of data. This is product data and text data and so on. This is some streaming data. So to understand the user more carefully, we need to handle different types of data as effectively as possible. And third type is called the velocity, and which is related to real time or speed. So the meaning of velocity is the ability to manage, analyze, summarize, visualize, and discover the data in timely fashion. It means that we need to support real-time performance. So in mobile devices, we need to consider real-time performance. And another example, we also consider the region we need to consider velocity is related to e-promotion or healthcare monitoring. In healthcare monitoring, we need to show the result directly to the users. Okay, and this is also similar when we show some promotional website. We need to show that website in a timely way. Otherwise, we just miss the opportunity. So this is more and more important concepts in big data processing. So these three are very important concepts for big data processing. And now we need to consider why the traditional conventional DBMS called RDBMS is not suitable for big data processing. Actually, there are several reasons, and the main reason is related to variety. So RDBMS, the conventional DBMS, mainly considers the structural data, but as I mentioned, the types of data are quite different. We need to consider semi-structured and unstructured data. For instance, this is an example of semi-structured data. As you can see, this data structure is similar to tree, and we call this is XML or JSON data. So this tree structure is dynamically changed. So to store this kind of XML or JSON data, the conventional DBMS is not suitable. And as the example of unstructured data, we need to consider audio, video, and image data. They are unstructured data. So to store this data efficiently, we usually use key value store. This is similar to hash. And hash structure is a little bit different from the RDBMS structure. So to address these data types, the conventional data is not suitable. Conventional DBMS is not suitable. So to address these data types, nowadays we need to consider another paradigm for the database system, and which is called NoSQL. And NoSQL, similar to big data, there is no formal definition for NoSQL, but usually NoSQL stands for non-SQL, meaning that it is no DBMS, no RDBMS. This is the opposite DBMS to conventional relational DBMS. So at the first time, we usually call NoSQL as non-SQL. So it is good for storing different types of data, but one disadvantage of NoSQL is is difficult to use, since it doesn't, at the first time, it doesn't support the SQL, which is the specialized language in RDBMS. But nowadays, NoSQL also support SQL. So nowadays, the NoSQL also stand for not only SQL. It means that this also still the NoSQL, the types of NoSQL DBMS also support SQL. This is for this concept we usually consider not only SQL. Okay. Anyway, so we are going to study the NoSQL in detail in the class. So before that, you need to understand the key difference between NoSQL and RDBMS. So RDBMS is good for storing relational data, but it is not good for storing semi-structured or unstructured data. But to address this problem, NoSQL is invented, and this is good for storing unstructured or semi-structured data. Okay. This is types of different data. As I mentioned, in the conventional DBMS, they usually consider relational data. This is similar to tables, and their support overlap. This is a conventional DBMS, but after NoSQL, they consider key value store to store unstructured data, and they also consider different types of data, including tree and a combination of relational and document and graph structure. This is a generalized structure for document. Anyway, so NoSQL stores different types of NoSQL store consider different types of storage, including key value, graph, document, and column-oriented data. Okay, so we are going to briefly cover some representative NoSQL for each type. And this is the overall procedure of big data processing. And we first collect the data. After collecting the data, we need to store the data. After storing the data, we do the data processing, and after the data processing, we analyze data. Finally, we need to visualize data. This is the overall procedure. And for each step, we use different types of application or different types of different types of software. Okay, so this is called big data environment. So in the big data environment, we try to integrate different types of different software together. So to understand the big data technology, someone just imagine that should we have to understand everything? Actually, the answer is not. In the big data processing, we usually use the Hadoop framework, and based on Hadoop, we try to combine some data storage and data collection as well as data analytics. Okay, we usually call this concept Hadoop ecosystem. Hadoop is one of the popular and representative big data processing framework. So in the Hadoop ecosystem, we can process the big data in a distributed way. And this is open source. So if you want, you can easily use the Hadoop ecosystem. Okay. So in the Hadoop ecosystem, you just consider the storage type as HDFS, Hadoop file system, and you can try to combine some data processing and analyze techniques together. This is a Hadoop ecosystem. So if you want to study the big data technology stack, you first understand Hadoop. After that, you try to combine different types of software together. This is the easiest way to understand the big data technology stack. Okay, and in our class, we also cover the Hadoop, and one of the homework is related to Hadoop, the Hadoop programming. So it means that using Hadoop, you try to implement some programming in a distributed environment. But when we consider the distributed system, some students may think it is very difficult, but using the Hadoop, we can easily implement the distributed file system, distributed data processing. So you don't need to worry about it. Okay. And lastly, we also cover the recent topic in DBMS called data mining. And data mining is related to data analytics. So when we collect the data, this is at the first time this is called data, but when we extract some useful data, we call this useful data information. But the information is already known data. So we want to know the unknown information, which is called knowledge. So the goal of data mining is to extract the knowledge. The goal of data mining is knowledge discovery from data. Here, the characteristics of knowledge discovery is interesting and non-trivial, implicit, unknown, and potentially useful. This is the concept of interesting. Based on 4 different concepts, we try to identify interesting knowledge from data. This is the goal of data mining. So the coverage of data mining is various, and in this class, as one of the representative example, let me just explain the association rule mining. Here in this example, we collect the data from Walmart, and in the Walmart data we can see a set of transaction data. Here the transaction means the customer buy a set of items together, and based on that transaction data we try to find some knowledge, meaning that what kind of items are frequently purchased together. And based on this data, we can analyze that milk and bread the customer frequently bought the milk and bread together. This is some rule mining, but this is already known. So this is information, but this is not knowledge. Here, based on the analysis, we find some interesting rule. Here the rule is if some customer buy the diaper, which means 기저귀 in Korean, and if some customer buy the diaper, he or she also buys beer together. This is quite interesting. We don't know why the customer tried to buy diaper and beer together. Actually, at the first time, we don't know why this rule is really possible and really feasible or really correct. We don't know that, but based on that analysis, we can find that on Friday or on weekend, many people try to buy the diaper, and since they are young, we are on weekend, they also try to buy beer together. This is kind of interesting rule. So the goal of association rule mining is to extract some unknown rule from the data, and based on that rule, we can use this rule to increase our profit in Walmart. This is the goal of data mining. So I will briefly cover the association mining in this class. Okay. So if you are interested in association mining, you can also try to search the association mining. Actually, this rule is very famous example for association mining. Okay, I just briefly explained the recent advancement in DBMS. So I hope many students are interested in this topic. So in I guess 2 or 3 weeks we will cover these topics. Okay, so If you have any question about this chapter, this presentation, just feel free to send email or just use the iCampus. Okay, thank you for listening.